Hello students, Ms. Slyman here with your 2.5 rational equations notes. So rational equations, of course we should know this word rational now, they have fractions. So there's two different methods, clearing the denominator method, which is the one that I love, where we multiply by the LCM and then solve as normal. The method that you guys seem to prefer is cross multiplying, which you've been calling the fish method. But you need to be really careful and make sure that you're multiplying and distributing correctly if you're going to use that. But I'm going to show you both. So in this case, I'm going to do method 1 over here, method 2 over here. So method 1 needs to first find the LCM. Well, my LCM of 3 and 4 is 12. So I'm going to multiply through by the LCM. So I've got 12 times 1 minus x over 3 equals 2x plus 1 over 4 times 12. Well, the whole point of the LCM is it causes the denominator to cancel. So 12 over 3 is the same as 4 over 1, and I don't even need to write that 1 in the bottom. 12 over 4 is the same as 3 over 1. So my denominators cancel. And like I said, I don't really need to even write the ones. Now I need to multiply out, and I need to be super careful to multiply by this whole thing. Remember how I said last video that division signs act like parentheses. So this is going to turn into 4 minus 4x equals 6x plus 3. And now I'm just going to solve as normal. And now I've run out of room. So if I'm going to solve as normal, I'm going to add 4x to both sides. That's going to give me 10x on this side. And when I add 4x, that turns into 0. I'm going to subtract 3 to put my numbers together. So when I subtract 3, I'm going to get 1 on this side. Divide both sides by 10. X is 1/10. And remember, we can use our calculator to check our answer. So we want to plug in this 1/10 here, plug in our 1/10 here, and make sure that it works. So now method 2, so over here we had method 1, and now here we have method 2, is to cross multiply. So we've got 1 minus x over 3 equals 2x plus 1 over 4. So we're going to cross multiply. I'm going to multiply 4 times 1 minus x and 3 times 2x plus 1. So step 1, cross multiply. And I end up with 4 times 1 minus x equals 3 times 2x plus 1. That's going to give me 4 minus 4x equals 6x plus 3. Well, notice I'm right back to here. It's the same thing. So in this case, I'm going to solve. I'll add 4x. So now I'm to step 2, solve as normal. I get 4 equals 10x plus 3, subtract 3. 10x equals 1, just like before. So x is 1/10. Okay, again, I'm going to show my two methods. In this case, I need an LCM of 5 and 2. That's 10. So I'm going to multiply everything by 10. So 10 times 2x plus 6 over 5 equals everything has to be multiplied by 10. 10 times x over 2 minus 10 times 3 over 5. Everything gets multiplied by 10. So now I can simplify. 5 goes into 10 twice. 2 goes into 10 5 times. 5 goes into 10 twice. I'm going to multiply out. I have no more denominators. They've all canceled. 2 times 2x plus 6 equals 5 times x minus 2 times 3. 4x plus 12 equals 5x minus 6. I'm going to move over the 4x because it's smaller. I have to move over the 6 because I want my numbers on the other side. 4x minus 4x is 0. 12 plus 6 is 18. 5x minus 4x is 1x. Negative 6 plus 6 is 0. So x is 18. Okay, here's where you have to be super duper careful in method 2. You cannot use the fish if you have more than one fraction on one side. So the first thing we have to do is use the lowest common denominator to make one fraction. So my left-hand side already is one fraction, 2x plus 6 over 5. My right-hand side, the common denominator is 10, so I get 5x over 10 minus 6 over 10. That means I say 2x plus 6 over 5. 5x and 6 are not like terms, so it's 5x minus 6 over 10. Now that I have one fraction on the right-hand side, I can cross multiply. So I'm going to end up with 10 times 2x plus 6 equals 5 times 5x minus 6. 20x plus 60 equals 25x minus 30. I'm going to move the 20x. I'm going to move the 30. So 90 equals 5x. Divide both sides by 5. X is 18. So we end up with the same answers, but notice in this method we ended up with much bigger numbers. I really like the clearing the denominator method. Just saying. All right. In this case, clearing the denominator method is multiplying through by x. So my LCM of denominators, this is an imaginary 1, is x. I'm going to multiply by x. So 3 times x equals 5 over x times x. Well, my x's cancel. 3x equals 5. Divide by 3. X is 5 over 3. In this case, it's very similar to your fish method. So I'm going to multiply and multiply. 3x equals 5. Divide by 3. X is 5 over 3. Okay, here I have only one denominator, 1 minus 4x. So I'm going to multiply everything by my denominator so it cancels. So I'm going to multiply 1 minus 4x times 3 over 1 minus 4x. I'm going to multiply 1 minus 4x by 4. I'm going to multiply 1 by 1 minus 4x. So in this case, I have two common denominators, so I have a 1 minus 4x over 1 minus 4x, so that cancels. So I get 3 plus, if I distribute here, 1 times 4 is 4. Negative 4x times 4 is negative 16x equals 1 times 1 is 1 minus 4x. I am taking up all my space. How am I going to do my fish method? Well, I will try to write smaller, starting now. So, all right, we had 3 plus 4 minus 16x equals 1 minus 4x. So I'm going to add 16x, subtract 1. Ooh, look, I have like terms. even with my like terms, I can put them all together with that minus 1. So these cancel. 3 plus 4 is 7. 7 minus 1 is 6 equals 1 minus 1 cancels. Negative 4 plus 16 is 12x. Divide by 12. X is 1/2. So now with this with method 2, and really I should have done this from the very beginning, even with my method. 3 over 1 minus 4x. Remember, I can't have two different things. So either I have to make a common denominator and put these together, or what I should have done from the beginning is just looked at that 4 and said, I'm going to subtract 4 from both sides. Then I have 3 over 1 minus 4x equals negative 3. So now if I make two fractions, I can cross multiply. So then I get negative 3 times 1 minus 4x equals 3 times 1. Negative 3 plus 12x equals 3. Add 3 to both sides. We get 12x equals 6. And x equals 1/2, just like before. And that's it. That's our last example. So really, even doing my method where I multiplied everything by 1 minus 4x here, I should have started by moving this 4 over and then just multiplied by 1 minus 4x. All right, I will see you in class.